Hello everyone. Today I will introduce my work, the TacticCraft language-driven tactical adaptation for StarCraft II. I'm the first author, Weiyu, and our team has Jiwen Jiang, Haobo and Haifeng Zhang. Most of us come from the Institution of Automation, the CASIA, the University of Chinese Academy of Science in China, and Haobo comes from the Tencent AI Lab, Shenzhen. This paper has been accepted to the first Muslim in machine learning workshop conducted with the ICML 2025. Well, at the beginning, I need to introduce the AlphaStar, the original of StarCraft II AI. The AlphaStar defeated the human player. However, although it is pretty strong and can defeat the programmer, it can't receive any human commands and adjust its own tactic. So human players cannot interact with the AlphaStar by language or cannot learn something more from the AlphaStar. It's just a pretty strong model, but we can't interact with it pretty good. Yeah. And by our previous research, we found that the tactics of StarCraft II can be described by language. We use LLM to label the tactical tensor and a vector which can present the policy behavior with the language information. And why we can do that? Because during the pre-train phase, we found that the LLM has learned a lot of knowledge about the StarCraft 2. They learned the build order, they learned the tactical tree from the StarCraft 2. From that, we can combine the LLM with DStar, an open source level AlphaStar, uh, enable the top tier reinforcement learning model to gain the language interaction ability and the tactical diversity. So our aim is to build a model which can accept the language in instruction. Yeah, but a previous reinforcement learning model just play the game. It can't receive any language in instruction. So first we must to learn the AlphaStar network structure. This is the AlphaStar network structure, and we can find that it organized by two parts. The left part we call it the perception block. The mission of perception block is to extract the feature. It can gain the feature from the given information, such as the RGB, unit position, and others. And the right hand is the decision making block. The most part of the making is completed by this part. So you can see here it has a lot of the action head and to generate the each part of action. Yeah. So if we want to fine tuning this model, the best choice for us is to fine tuning the decision making block because the perception block is trained pretty good. So after that, we need to gain the data. First, we have a lot of StarCraft 2 replay, and we can use the DSStar code to decode the replays into the natural language. We call that build order. It can just show the macro things from the StarCraft, and then we can get a lot of human-centered data from the communities and the internet. The swarming pool provide a lot of community data, and the Team Liquid provide a lot of match data. These data can help us to gain the strategy elements. The human experts can summarize the strategy names into 9 categories. The first is the early, mid, game, all-in, or rush strategy. So it is pretty important for us to classify the game into only 9 parts. So from that we can use the large language model to help us labeling the data. After the labeling, the data format could looks like that. And now we can train our model. In this work, we use the adapter to fine-tuning our model because the reinforcement learning node is not large enough. And we also use the KL divergence to control our original policy compared with our training policy. Yeah. So here we found that here we use the tactical tensor to train an every adapter, and any other human players will provide the language in instruction, and this instruction will be translated into the tactical tensor, and our trained model will influence interact with the game one by one. So let's see some demos of that. The first is the early quick three basis tactic. It produces a lot of worker and use the billing to push the building AI. Another tactic is just use the third base plus one juggling. Our model build a lot of jugglings and research the many plus one. Can also use the two-base commuter. So you can see here our model produce a lot of muta and it's related upgrades here. So here let's show our demo here. The first we just need to type our strategy text. Yeah, I want to expand the service quickly and focus on economic development. This is our language instruction. And that's the LLM will receive the language instruction and generate the tactic tensor. And then the game will run automatically. Yeah, you can see here. Our model build this quick natural base and then build the third base, I think. Okay, it's build this, it's use some juggling scale and build the third base. Put down the building nest. Okay, and use the juggling building pressures. Okay, he found some roaches here and transform and still build the juggling to give some pressure. We can see here the building AI cannot construct the third base, and we have the third base, so our model has a better economic. Yeah, and up and complete the missile plus one research. Yeah, yeah. Okay, just push, pretty strong. And finally, we deny the third base again, and the roach push up to destroy the building AI's enemy. So it's pretty important to find a good strategy and follow the language instruction to destroy the enemy. So here we have the different type of strategy, and every strategy can follow the language instructions.